Hi everyone, this is the first Milestone video of my project. In my project, I selected the research track with my mind set on applying visualization tools and techniques to the teaching of linear algebra field. The main purpose of this experiment is to compare the effects on students' mastery of linear algebra concepts before and after using visualization teaching. The reason why I do this is that there is a natural connection between linear algebra and visualization teaching, because many concepts of linear algebra are closely related to geometry, and many operations of linear algebra can be presented geometrically. First, let's take a look on the overview. My project mainly covers three parts. The first part mainly talks about the vector, and the second part mainly talks about the matrix, and the third part mainly talks about some other relevant content of linear algebra. This video is just taking you through the contents of this project so you can have a general understanding of it. For more details, you can watch other videos in this playlist. The first part is the vector. The purpose of this part is to arouse people's memory of linear algebra, so this is mainly used for a warm-up. This part mainly introduces the basic knowledge of vector, including the starting point of a vector and the order of the number in a vector, and also the row vector and column vector, and the geometric representation of vector in different dimensions. Next is the basic operations of vector. I will mainly introduce three basic operations in this part. The first one is vector addition. I will introduce its operation process and the geometric explanation. The second one is scalar multiplication of vectors. I will also introduce its operation process and its geometric explanation. Before introducing vector multiplication, I will introduce the concept of mode, which is the length of a vector, and the operation process of mode. On this basis, I will further introduce the concept of unit vector and the standard unit vector. Next is an important part of my project, that is vector multiplication, which is also known as the dot product. First of all, I would like to introduce a common mistake regarding how to calculate dot product. And then I will point out the correct calculation process of dot product. And you may wonder why the multiplication of two vectors is defined in this way, and why the result is a scalar rather than a vector. In order to explain this, I will start from the geometric view of this definition. First of all, I will show you an equation. On the left side of the equation is the definition of dot product, and on the right side of the equation is the geometric interpretation of dot product. Next, I will prove that these two are equal. During this process, we'll use the cosine theorem. Then, when we have finished the proof, I will introduce to you what the geometric meaning of the right side of the equation is. In short, the logic behind this geometric meaning is that two vectors that are not in the same directions cannot be multiplied directly, because the result of this is meaningless. So if we want to get a meaningful solution, we need to map these two vectors to the same directions, as shown in the picture. Because the left side of this equation is equal to the right side, and because the right side has a reasonable geometric interpretation, so we can say that the left side is the definition of dot product. Then I will introduce the application of dot product. For instance, the recommendation system, that is, by determining whether the angle between two vectors is equal to 0, greater than 0, or less than 0, we can determine whether the two vectors are similar, irrelevant, or deviate. Next is the third part, matrix. First of all, I will introduce the concept of matrix. Then I will introduce two basic operations by matrix, that are matrix addition and scalar multiplication, and I will introduce their geometric explanation. Next, I will discuss the matrix from three aspects so as to provide a new perspective for you to understand the matrix. First of all, I will elaborate on the first perspective of the matrix, that is, see the matrix as a system. I will discuss in detail how to represent a system by using matrix. We can construct a problem by several equations, and these equations can be processed into matrix we used to see. Then I will explain the origin of matrix multiplication in a way that is easy to understand, that is, a row multiplied by a column. Next, I will elaborate on the second perspective of the matrix, that is, the matrix as a function of vectors. I will introduce this perspective to you through the case of graphical transformation. I will introduce some typical topic of graphical transformation such as stretching, flipping, and shear parallel, so as to deepen your understanding of matrix multiplication. And we will discuss why a matrix can be regarded as a function of vectors. Finally, I will elaborate on the third perspective of the matrix, that is, the matrix as a space. Before any discussion, I will take you to look at matrix multiplication from the column vector perspective, and introduce the method of regarding matrix as space through the example of standard unit vector. Then I will show you some examples. I believe that after this process, you will find that matrix multiplications turn out to be so easy. We will also looking back at the graphical transformation we discussed earlier. And you'll find that many transformation matrices that we spend a lot of time to calculate can be now easily derived from the perspective of column vector. Finally, I will introduce some other relevant content in the field of linear algebra. Then I will introduce linear combination, linear dependence and independence, and here I will introduce an important property of linear dependence. In order to better understand this property, I will provide some geometric explanations. Next, I will introduce determinant. In traditional classroom, professors only gives the calculation process of determinant, but in my videos I will explain the geometric meaning of determinant so that you can have a more intuitive understanding of it. Similarly, in the traditional classroom, teachers rarely talks about the meaning of eigenvalues when they teach eigenvalues and eigenvectors. In my videos, I will let you see the geometric meaning of eigenvalues and eigenvectors so that you can understand the necessity of inventing such concepts. Finally, I will introduce principal component analysis. I will tell you what core idea of principal component analysis is through two dynamic diagrams. I believe that through these two examples, you can have a deeper understanding of PCA. Thanks for watching.